want to take the time to talk a little bit about the anatomy of a mask. What we have here is you hear a lot about melt-blown polypropylene. This is actual virgin melt-blown polypropylene, single layer by itself without any spun bond on it. It has a slight rib, but you can see very clearly it's just a very thin but very extremely durable sheet. It's very scratchy. You cannot put it against your face. It'd be too rough. You just see all the little strands and hairs. They've blown this together and melted it. On each side of that, what you hear with the SMS material is spun bond, melt blown spun bond. This is a spun bond material here. It's a different procedure. It's a softer. It's what we use on the inner and outer shell of our masking systems. When we use the spun bond, we also use the halyard SMS as well. The halyard 400 and 200s, which have a bacteria filtration efficiency of over 99%, which we like. This particular melt blown has Nelson Labs came back. It says a BFE rating of 95, but when I read the Nelson Labs report, which we of course have available when you buy your mask, it says 97s and some 96s as well. So it is very, very, very near the 98% or greater that an N95 mask would have. But we have that, and what you'll see is 3 layers. Or in this particular case, this is a halyard 400. I know they get cranky about using it, but it's an excellent alternative use. The PFE and BFE ratings are equal to or greater than an N95 mask. And then, of course, we've demonstrated in the other video our vapor, blood droplet, or water penetration or fluid penetration test. They demonstrate that, but you have that. It's been cut. So it shows 2 layers, but when they come in a single sheet, there will be these 2 layers fused together. But that in itself is the anatomy of a mask. It is the spun bond, melt blown spun bond, or in this case, the virgin melt blown here itself, between 2 layers of spun bond. But it's very thin, very durable, has a high delta rating. This is a delta flow rating of 8, which is in excess of the 5 liter per minute flow rate an N95 requires. And you'll hear a great deal about 95 or N95, and what's really been missing from the equation in the conversation of these masking systems, these fly-by-night Tom, Dick, and fools that build their alchemy and junk science, is the delta flow rate is so important. Is that you don't trap carbon dioxide between your face and the mask to be re-inhaled. So the utilization of these things, if you're purchasing masks that don't have any documentation, any substantiation, any sanitization procedures, any construction methods, any material layers, the raw goods put into it, how it was constructed, be very, very leery of the junk that you're buying. There are fools out there who think they know everything. They think they're superheroes. They have nothing but cartoons with fancy color graphics building junk. So just be very careful what you put on your children's face. Be very careful that you select a mask system that's designed to protect you and keep your children alive. We've put a lot of hundreds and hundreds and hundreds of hours of research into understanding the anatomy of a mask and understanding these materials, understanding each and every one of the values assigned during testing procedures to N95s and ATSM level 3 masks, which is another exceptional mask with regard to protection at ATSM level 3. And quite truthfully, it's nearly identical to an N95. It simply does not have the fitment testing involved. So we've designed our masks to fit very properly, as opposed to a 3-pleat or a 3-layer. The 3-pleat mask you see a lot of the procedure mask or non-surgical mask that you see. We put a lot into it, and I'm going to discuss our construction technique. But I want to talk a little bit about the anatomy of a mask itself and what those materials are. And let you see them in their raw form so you understand what you're purchasing.